Way 61 deals with more math and chemistry, and this deals specifically with the density formula. And you know that the density formula is provided to you on table T, where density is equal to the mass divided by volume. If you look at the back of your reference table, it already tells you this formula. Please note that specific density values for elements are also provided on table S. So if you ever need to look up the density of a specific element, you can also look that up on table S. So you may need to consult both the density formula as well as table S in order to answer some of these problems related to density. Let's try one example. A student measures the mass and volume of a sample of copper at room temperature at 101.3 kilopascals, which you should know from page 1 of your reference table refers to standard pressure. The mass is 48.9 grams and the volume is 5 cubic centimeters. The student calculates the density of the sample. What is the percent error of the student's calculated density? Now, this problem is deceptively simple, but if you are able to apply the density formula as well as the percent error, you can figure out what the percent error is. Okay, you'll need to consult the theoretical value for the density of copper, and you notice that its density or actual density is 8.96 grams per centimeters cubed. If this is the actual density of copper, you need to calculate the measured density of copper. If you measure 48.9 grams in a volume of 5 cubic centimeters, you're going to need to calculate the density. Doing that, you'll also then need to apply the percent error formula, which takes your measured value minus your accepted divided by your accepted times 100. So let's do that. You're given a mass of 48.9 grams divided by 5, which will give you 9.78 grams per centimeters cubed. Now, this is your measured density. This is what the student measured in the problem. What is the actual density of copper? Well, if you look on table S, it's 8.96. So then you just simply plug in these values in your percent error formula, and you'll be able to get your percent error. The measured value, you calculate it to be 9.78 minus 8.96, which is the actual, divided by 8.96 times 100. You get 0.82 divided by 8.96 times 100, and you calculate it out to be 9.15%, which would take you to answer choice 3. So all this for what looks like a simple problem. So please note that you may have to consult table T, table S. Sometimes you might have to apply the use of percent error, also provided on table T. So let's try another problem that deals with density. The graph below shows the volume and the mass of 4 different substances at standard temperature and pressure. Which of the 4 substances has the lowest density? Now, if it's asking, now notice that the graph shows you the y-axis of mass and the x-axis in volume. So how would we use this information in order to calculate the density of any one of these substances? Your knowledge of algebra should make you notice that when you calculate the slope of this line, you have to calculate the mass, the change in y over the change in x, which is the mass divided by volume. So how do we calculate the density of substance A? Well, we would use the slope of line A in order to calculate its density. It's asking you which of the 4 substances has the lowest density. So it's basically asking you which of these lines has the lowest slope. And you should note that the steeper the line, in other words, the more incline, that the larger the slope. And the larger the slope corresponds to a larger density. So which one of these should have the lowest density? Which should be the one with the smallest slope? The one with the smallest incline, which is line D. Therefore, line D has the lowest density because its slope is less steep than the other lines present. Line A has the largest density because it has the largest slope. And notice that whenever you're given a mass versus volume graph to calculate the density of any one of these lines, we would need to consult the slope. At STP, which physical property of aluminum always remains the same from sample to sample? You should note that since we're talking about aluminum, it's going to retain the same physical properties of density no matter what we do to the sample. So we can easily change the mass of the sample, the length of the sample, or even the volume, but its density will always remain constant if we're talking about solid aluminum, for example. So the correct answer is 2. Next problem. At 1 atmosphere, equal masses of solid H2O, liquid H2O, and gaseous H2O have. This is asking you to apply knowledge of how solids, liquids, and gases behave. And you should note that solids are going to be generally more compact compared to gases, which are more expansive. So you would expect solids, liquids, and gases to occupy different volumes, not to be the same density, even though, because we are changing phase here. But notice that the volume of solid H2O is going to be slightly smaller compared to gaseous H2O if the mass is the same. Why? Because gaseous particles expand compared to solid H2O, which would be ice. So you can think about how water behaves as it changes phase, and it would occupy different volumes. So remember, when it comes to density, you always have the formula on the back, table T. Density is equal to mass over volume. Occasionally, you may need to look up the actual density of a specific element, in which case you can use table S. And then sometimes you might have to calculate the percent error by using the percent error formula and compare it with the measured density compared to the actual density listed on table S. So these problems involving density can seem simple, but actually be quite complex. Try not to get confused. Thank you for watching. Hopefully this was helpful.